So you need to work with the agent. So in this case, we're exploring sort of these interesting issues where the human would delegate to the agent the optimization of charging the battery, the optimized charging of the battery. And we've studied how people understand the sort of practical repercussions of having to balance their everyday practices against their monetary payoffs. And hence, really sort of investigate the question where we see agents integrated in systems where it rubs against the daily practices. It really affects the daily practices. So how did we do that? We basically took some real-world data. We took some wind data sets from across England. We created a price profile based on this wind data set. So something that could change across a day and over a week. And then we simulated this battery, this virtual battery, which allowed us to simulate this sort of against this simulated energy price. So the agent would look at the energy prices, charge the battery when it was cheap, and deliver this energy when the washing machine was ready to load. And what we call agent B, so the battery agent, basically, was designed to be in the background. It was not meant to be in the foreground, so it was not like a virtual agent sitting there, so hello, how are you, do you want to charge your battery today? No, it was not like that, it was not like paperclip. It was hidden in the background. Okay? So agent B calculates the best time to charge. And the way the interaction with agent B was designed was such that users needed to book washing. This is how they interacted with the agent. They booked their washing for a certain time of the week. They were made to think about it, and we forced them to think about it in this case. We really wanted this to annoy them and see how they react to this, and whether they comply and see the benefit of complying. That is, if they comply with their booking, so they book and then react and then act upon it, so they actually run their washing machine load when they should, they make some savings, they earn some reward for it, so we pay them some money based on how much it costs them to run their washing machine at certain times of the day. So basically, the user had to book a washing machine load for a certain time. Each time they would book this washing machine load, they would pay a price for having run their washing machine at that time based on the price of electricity. The agent would help them reduce that cost by storing energy before. We would reward them sort of $50 minus this cost. Okay? And the sum of the cost across 15 washers. So this is the interface that they used to book a washer. It was a simple calendar interface. So they would click on this interface, if I can do a live demo. So this is the video. So they would click on this and book a washer for a certain time. So you might say, I want to run a light or a wash or a cotton wash at 40 degrees. And then the agent will calculate the price for this wash. So you look at a prediction of the price for the week ahead. And tell the user, this is the price of electricity for the week ahead, for different slots of these days, so Monday, Tuesday, Thursday, Friday, etc. So then they could book a specific slot by clicking on one of these big slots. So once that's booked, it goes into the system, and the agent knows that it needs to store energy at that time, before that time, in order to deliver this time. Right, so you see the slot in the calendar interface there. Now, if the user tried to book another slot after that, the battery would not be charged, obviously, the cost would be higher, and that was obvious from the price of the book. And we will also be able to perceive the savings made by booking using the agent. Now, since the agent has to predict future prices for electricity, remember that these are predicted prices and they're predicted based on wind availability. So the agent is doing work for the human. It's predicting what prices will be in the future, and then deciding to charge the battery. Now, if the prices change, the cost of the washing machine load will change. Right? So I've booked to run my washing machine on Saturday, and the wind is not going to blow before that, hence the price will go up. The agent will notify me with an SMS saying, or an email saying, the price has changed, do you want to rebook this wash? And we have thresholds to send that message. So sometimes, if the increase was not too high, we would let the wash go through. And the user had to set those thresholds. So, okay, if it's only 10p, let it go through. If it's 50p, then definitely notify me and I'll rebook it. And they could rebook it right on their phone. So they could go to that slot and book it on their phone. So what we are trying to engineer here is the notion of control, so some flexible control. So the agent is automatically booking, sort of charging the battery and reacting to these real-time prices, but also giving back control to the user when things are going a bit fuzzy, right? When the prices are changing too much. And the user could always go online and check the dashboard, and they could see how many washes they've done, the amount of the money still in the bank. So we told them you have a budget of £50, and we keep deducting the cost of the loads that we run. And you could see the status of the battery and whether it's charging or not, based on the current availability of energy, price of energy. You could also see this on the app, on the phone. It's a web app, so it's very easy to use. And we implemented it using very basic web technologies, Django Python for the server side, for the energy monitoring side. So we actually monitored when they were washing their clothes. So we had these kits from a company called Alert Me in the UK. So these actually transmit the energy consumption data from a smart plug to a server and can monitor that. We could actually switch off the appliance if we wanted to, but we didn't. We wanted to leave control to the user. So we could monitor everything and what's going on. And we trialed that system. So we built the system, so we built a prototype, we tested it ourselves at home, we checked whether it worked, we made sure that the messages, the SMSs were going through when the prices was going up, and we would monitor we would also notify the user that there was a wash due, and we make sure that it works for them, so they get notifications at the right time, giving them enough time to go and load their washing machine. So we did this with 10 homes. We let them experience 15 hours of washing. So we didn't just give them the app and tell them to play with it for 2 weeks. We told them we will take away the app when you've done 15 hours of washing, just to make sure that they end up with enough experiences of the system to learn to give us enough data. And we told them about this sort of future energy scenario, not the current scenario, but set in the future. And then once the system had been tested and deployed, and we took back the equipment, we did these semi-structured interviews. So we had carried out interviews before the experiment, and we did some interviews after the experiment. And these semi-structured interviews are meant to be, as the name says, is semi-structured. So you have some basic questions that you ask, and then you probe deeper as the user answers some questions. So you let them say, okay, yeah, for example, some user might say, I don't think the app saved me much money. You say, okay, so then you say, why do you think that? So what did you use the interface to confirm that? And you probe deeper and deeper and deeper. So then you don't fix yourself to like a survey type answer sheet, right? So if you just have fixed questions and you just ask people to respond to your survey, you would not get sort of the rich information about why they actually did something. So we did those semi-structured interviews. We recorded the interaction logs, so how much they clicked on things on the website, how much they reacted to the SMSs, etc. And what we found out was that the system was perceived as an organizer. They didn't see an agent. That was a success, actually. We didn't want them to see the agent. So they didn't see that the agent was charging the battery. They just saw the prices. For them, it became a way of organizing their lives. So it forced them to think about when they should wash their clothes. Students become more organized. They start thinking, okay, if I do this every Saturday at this time, then I'm always going to have fresh clothes to wear the next day and the next week. The battery and the agent seemed hidden to most participants. No one really talked about it. So the system was doing really well for us. There were tensions. There were people who said, I can't actually deal with this kind of system because I have 3 children and I have to wash clothes when I have to wash clothes. I'm not going to start booking things in the system. So for some users, it doesn't work. You can't force them to organize themselves in that way. They have to be more reactive, and therefore you need to build a maybe different system for them. Something that's more automated might be more acceptable to them. So they would be okay with letting the agent charge at whatever time and shift their loads and store the energy whenever they thought it might be okay. So maybe model them a bit more. And this sort of raises implications for designing for smart grids. So you need to there's an interaction design trade-off. You could let the agent learn about human behavior and try to predict when you're going to run your washing machine. Or you could let users take control and actually tell the system when they're going to run your washing machine. So there's a big trade-off between these two. We also don't know how people will engage with the systems in the longer term. You do an experiment, you do a field trial of a human agent collective, and you get results over a 2 weeks, 3 weeks period. How do you know whether they will take up these behaviors in the longer term? You might just be excited about your system. Also, it raises questions about trading utility for convenience. In this experiment, we had to pay the users an artificially bloated price for, we had to tell them there was an artificially bloated price for energy. So they were, in England, if you pay for electricity, you pay about 15 to 20p pence per kilowatt hour. In this experiment, it was maybe 5 to 10 times more than that. And that got them thinking about the cost. But if the cost is too low, they won't react so much to these prices. So they won't be able to perceive the utility in shifting energy consumption. And we need to think of other ways of incentivizing them beyond cost, I think. And HCI can possibly help with that. So this is the main point. Okay, so summarize the key points in this set of slides. I've gone through the interaction design loop with you, so I hope you understand the importance of prototyping, of testing or evaluating your system in field trials, lab study, or use of force techniques. And then how that impacts on design. I've also mentioned ways of defining better interfaces in terms of user experience and usability, so the different metrics. And given an example of a demand response agent as an example of a human agent collective, and showed you how we evaluated a human agent collective. And also showed you how to carry out this small sort of scale field trial. And these results are publishable. We have only 10 homes, and we did this qualitative study. And it was publishable in a conference like this. Some things like that are also publishable at AMAS if you shape it in the right way. And you should not worry so much about making your agents very, very sophisticated to get your equipment to conference. The important thing when you do human agent interaction is to have really interesting results on how you build the right interaction modalities between humans and agents, what you learn in your deployment, what you learn in terms of how people react to your agent's cues, to your agent's instructions in your paper. And definitely recommend reading this book by Mrs. Dutchman on Cloud Distributed Action to understand how to do this better. It's a very difficult book to read. I haven't read it completely, but it's definitely an interesting read. Okay, so I'm going to go into the last part of my talk, and I think we're going to have the coffee break now. But when you come back, I'm going to introduce you to this group activity that I want you to do outside, so we're going to go outside. So have a coffee and come back in half an hour, right? And I'll go through some introductory slides, and then we'll get to design a human agent collective and think about the evaluation of this human agent collective, and then we'll come back and wrap up at the end and maybe get some of you to present what you've come up with. Okay? So let's break now, and in the meantime you can think about this question, but feel free to go home.